1C Enterprise is built to scale, from small retail shops to plants with thousands of concurrent users. But how does it carry that load without crashing? It starts with the server cluster. Let's look under the hood of a 1C cluster. 3 executables run the show. First, ragent.exe, the server agent. It's the orchestrator. It launches the other cluster processes and maintains the registry layout on its host. Second, rmngr.exe, the cluster manager. It oversees the operational logic of the whole cluster, and the server that hosts it is recognized as the central server. Third, rphost.exe, the worker process. This is where the heavy lifting happens. It serves clients directly, executes application code, and talks to the database. And a cluster can spin up many worker processes across different physical servers, scaling almost infinitely. A crucial evolution in 1C was separating the application state from its connection to the worker process. Session data is now cached outside of rphost.exe in a dedicated session data service. So when a worker crashes, the client's next call automatically switches to an available worker. In most cases, that handoff is completely invisible to the user. But how does that retry stay safe? When a call fails mid-flight, the system first checks the session data. What already happened on the server? If the attempt left traces, say a closed database transaction, a blind retry could corrupt your data, so the client gets a fatal error and has to restart. But if the call left no traces, a report, a form view, the system simply retries behind the scenes. The user sees a 1-second freeze, then work continues. Traces means stop safely. No traces mean retry silently. Data consistency always wins. To erase even that tiny lag, 1C adds a mechanism called workflow backup, configured per infobase, not globally. Mark an infobase as reserved, and the cluster spins up a standby worker that preloads its metadata ahead of time. If the active process dies, sessions jump to the prepared backup instantaneously. It becomes the active worker. Its backup flag clears, and a fresh standby launches to restore protection. Scale that idea, and with multiple physical servers, you get full cluster-level redundancy. If an entire node goes offline, the remaining nodes absorb the load seamlessly. That's an active-active layout. Every node is working, and every node covers the others. So, how does the cluster decide who handles a new user? It measures constantly. Every rphost.exe streams its live metrics: CPU utilization, call counts, execution times, connection waits. All of it feeds straight into the main cluster manager on the central server. Counting connections isn't enough. 10 light users can strain a server less than 2 heavy report builders. So 1C computes a dynamic metric called the performance index for each process. The closer it is to 0, the freer and more efficient that process is. Process A idles at 0.10. Process B, crunching reports, sits at 0.80. When a new session arrives, the manager routes it to the lowest index, process A, optimizing your hardware automatically. Workloads shift all day, so the cluster also rebalances on the fly, quietly moving background sessions to quieter nodes. Administrators fine-tune this in the server administration console under functionality assignment rules. Target a specific object, here, the session data service, set the requirement type to assign, give it a priority to match your infrastructure, and save. The cluster now balances your way. Process isolation, instant backups, performance index routing. Together, they make the 1C Enterprise server cluster a self-regulating, enterprise-grade framework. Review your assignment rules now and then, and it keeps itself optimal.